one, they're obviously practicing the proportions that we're dealing with and practicing the concepts of cross products. But it also brings in some algebra that we talked about maybe 3 or 4 weeks ago. Spent a couple days on it. And then a couple weeks before that, we spent a couple days on it. And a couple weeks before that, we spent a couple days on it. All right. And throughout the year, we periodically came back to factoring, haven't we?
A little bit.
All right. Talk about a little bit. And then we've seen it maybe in a couple assignments, and then we get away from it, and we come back to it. Talk about it, see a couple assignments, get away from it, and we keep doing that. You're going to start seeing more and more factoring as we move through the rest of the year, and that's what these questions here deal with. That's what tonight's homework's going to deal with. So these are very good questions to be talking about. But the number one thing we got to realize is that we are going to look at cross products, right? We're going to multiply those things together. So when I multiply the 8 and the 2, I get 16. And we know that should equate to x minus 4 times x plus 2, right?
Oh, so then you minus 2 and then add the 4. We got a FOIL.
We need a FOIL.
I hated that. That's ridiculous.
Your order of operations tell you that is important, okay? That has to be done first before you start adding, subtracting the 4s and 2s and that kind of stuff. So, if you remember foiling, everybody can distribute, right? Everybody can do this, x and x plus 2.
Maybe.
Everybody can do that? Okay? That's all we're doing here. I'm taking x times x. Gives me x squared. What's x times 2? What's x times 2? 2x. Okay? Now, could everybody maybe do this? Could everybody take negative 4 times x plus 2?
Yeah.
Okay? So let's do that here. Negative 4 times x gives you negative 4x, right?
Yeah.
Negative 4 times 2 gives you negative 8 equals my 16. So when you guys do foiling, okay, foiling, F and O, we're multiplying that thing times these two. So this is the F and O, and I and L are distributing that to that second part. So that's your I and L. Does that make sense? So the foiling process, that phrase, is just to remind you that you're going to distribute both of these things individually to both of these things. Okay? So we get this equation here, and it probably makes sense to go ahead and rewrite this as x squared. Let's go minus 2x minus 8 equals 16. I just combine my like terms, right? Now, here's where, and you could have done this in the same step, but I want to maybe be a little bit more deliberate. We start seeing these powers of 2 now develop, right? What should come to mind? What algebra should come to mind when we see powers of 2? Factoring, which is, you're right, it's algebra 1. Okay, so we want to factor. And when we want to factor, we always set things equal to
0.
Set things equal to 0. So what do I have to do with that 16 here?
Minus 8.
Minus 16. And I line it up over here with the constant that is there. So subtracting then gives me x squared minus my 2x. So negative 8 minus 16 gives me negative 24, right? Okay, so right here is the geometry that we learned yesterday with the ratios. If you set that up, if you told me that you know that the product of the extremes is equal to the product of the means. This stuff here and everything that we do beyond that is algebra 1. Okay? If you remember back to algebra 1, when we saw x squared, when we want to factor, get things equal to 0, we're looking for two numbers that multiply together, give me that, and add up to give me that. Negative 6 and 4. Okay? So what happens then, because this is a 1 right there, and because that's a 1 out front, this thing and that thing can be called 1x and 1x. And then we put in the numbers that he gave me where you say negative 6 and positive 4?
Yeah.
All right. So what we've done here is we have factored this thing. And when we factor something, essentially what we're saying, when we factor something, we are looking for the numbers or the objects that we multiply together to get a product, right?
Yes.
So x minus 6 and x plus 4 are being multiplied together, and they should give me the product of x squared minus 2x minus 24. And if you took x minus 6 and x plus 4, you FOILed them out. That's the multiplying of them, right? you get that red phrase x squared minus 2x minus 24. Okay? So I know that's correct. But the reason we do this, the reason we write it this way is because now I can use the property that when I multiply these two things together, I multiply two numbers together and I get 0, either that number, x minus 6, had to be 0, or that number had to be 0. And it allows me to kind of hone in on what those x values had to be. Okay? If this number here was not 0, then I cannot hone in on what x has to be.
What's going on?
Huh?
Hone in mean?
Yeah, kind of narrow down, view, change my view, start to zoom in, that kind of thing. So, that's what we get. X is 6 and x is negative 4. Now, why does that make sense, or does that make sense? Do both answers make sense? Come back up to our ratios. If x is 6, what would this numerator right here be?
2.
2, so I get 2 over 8, right?
Yeah.
If x was 6, what would this denominator be? 8. Would you agree that that's a true statement? 2 eighths equals 2 eighths?
Yes.
Okay. What if x was negative 4? What do I get if I put negative 4 right here for that x? What's negative 4 minus 4?
8. Negative.
Negative 8. And what do I get if I put negative 4 right here?
I don't know.
What's negative 4 plus 2? Negative 2? Are those two things equal? Yeah, they both reduce to what? Negative 1. Okay. So that is verification that both those things are answers. All right. That kind of makes sense on how to do that last one?
Yes.
Or one of those last ones? Now I'm going to write this as, we had x squared minus 2x minus 24 is equal to 0, right? You guys remember dealing with this thing last year? And we've already talked about it a couple times this year.
Oh, yeah.
What do you call that?
What's the name of the formula?
Yeah,
Is it quadratic?
it is. Good job. Quadratic formula. And the quadratic formula, what that allows you to do, so what that allows you to do is factor anything that is of this format, anything that is in the version of ax squared plus bx plus c equals 0, where a, b, and c are elements of your real numbers. Okay, so a, b, and c are just any real numbers they want to be. And right now we see that a is that 1 right there, b is negative 2, and c is negative 24. Is that right? So now let's just plug that stuff into this formula. Opposite of b, what's the opposite of negative 2? 2. And then we got plus or minus. All right, now we're going to take b squared, so what's negative 2 squared? Negative 2 times negative 2 is, good, 4. Minus 4,
0.
a would be 1. What's c? Negative 24, right? All over 2a, and a was 1, right? So 2 times 1 would just be 2. Now we got some order of operations to deal with in there and evaluating. We got 2 plus or minus. Now it's going to be 4. When I take negative 4 times 1, you get negative 4, right? What's negative 4 times negative 24? It's a positive, so 4 plus. So now what's 4 times 24 then?
96.
96. All over then 2. So now, what's 4 plus 96? 100. So I get that, right? But what's the square root of 100? So I get that. Now, the issue is what the plus and minus means. It means you have two answers. You have 2 plus 10 divided by 2, or you have 2 minus 10 divided by 2. What's 2 plus 10 divided by 2? 6. What's 2 minus 10 divided by 2? Negative 4. Are those the exact same two answers that we found using that other technique? Okay. The quadratic formula is something that you guys need to burn into your memory and never, ever, ever let it escape through all the math classes you take beyond this, because it's going to be one of the largest, most integral formulas in the part that it plays in Algebra 2, college algebra, trigonometry, integrated 3, integrated 4. Even when you get into physics class, we use that quite a bit. We use it in other science classes. It is very, very useful. Okay? But it allows us to factor anything ax squared plus bx plus c equals 0. Any quadratic equation. Anything with power of 2 being the highest power. Yes, please.
Number 3 is the question.
Huh?
I don't remember how to do 32 or like factor or foil, whatever, when it's like a number and then x squared.
Okay, so you're saying that you struggle with 32.
Yeah.
Question 32. Let's do one of those. All right, so this one, we're going to do the same thing. We're going to cross multiply, right? So the geometry is the same. 1 times 1 plus 11x is 1 plus 11x, right? I'm going to cross multiply the extremes, which are those two. I'm just going to write it down real quick. 5 minus 9x, and then 1 plus 4x. Right that way. And now I'll just go ahead and foil this side. So it gives me 5 times 1, which is 5. 5 times 4x is 5 times 4x?
20x.
20x. And now negative 9x times 1 gives me negative 9x. And now negative 9x times 4 gives me 36. But it's x times an x, right? So it's x squared. So now I'm just going to go through and just kind of combine like terms here. Get this in a more condensed version. So we got 5, what's going to give me 11x minus 36x squared. So I got this 1 plus 11x over here. Let's this one's going to be a little bit easier than some of the other ones. So we'll maybe see another example here in a minute of this. Subtract 11x, what happens? X's go away. Subtract 1. So I get 0 over here, and now this is equal to 4 minus 36x squared, right? Okay. Now, this one's a little bit easier than others because there's no x term left over, right? A lot of yours probably this is just kind of coincidental with how that set of terms there worked out and related to essentially that there, okay? This set of terms give me 11x, and I already have 11x over here, so they cancel out. That's not always going to happen. But if this happens, if I don't have a middle term, okay, in the version ax squared plus bx plus c equals 0, that's my ax squared, that's my c. I don't have a bx, right? I don't have anything raised, any x variables raised to the first power. If that's the case, you can do these questions pretty easily. I'm going to add 36x squared to both sides. And I get that, right? Can I divide both sides by 36?
Yeah.
So x squared is equal to 4 divided by 36.
Yeah.
Now, what am I going to do to both sides?
Square root.
Square root. Okay, so my square root, now here's the only thing, you got to pay attention. You get two answers. You get plus or minus the square root of 4 over 36. But what's the square root of 4? 2. What's the square root of 6? Or sorry, 36. 6. So I get actually plus or minus 2 over 6, which is actually going to reduce to plus or minus 1 over 3. So there's my answer for that one. That's a unique situation because we don't have a b term. And if you don't have a b term, you can use this process. It's called the square root method because that's what we did. We isolate the x squared, take square root, solve for an answer, right? Do you have yours in front of you that didn't give you one like that?
Yeah.
Can you read to me?
Like the whole thing?
Yep.
7 minus 6x. 3 minus 6x. Oh. 7 minus 6x. Over 2 plus 3x.
Hold on. 3 minus 6x.
Minus 6x. Over 2 plus 3x equals 1 over 2 plus 3x.
Okay. So looking at same concept, and regardless of the coefficients that you're using, the constants that you're using, the process is going to be the same for everybody. So when I cross multiply those, I get 2 plus 3x, right? When I cross multiply the extremes, I get 3 minus 6x, 2 plus 3x, correct? Yes?
Why don't you just do 6x times 3 equals 1?
6x.
So it's like, both of the denominators are 2 plus 3x.
You can do that.
I don't know. It just seems easy. That's what I did first.
Yeah. Well, let's see. We'll go 2 plus 3x here. Because maybe if you don't recognize that, this would be the approach that you use. Okay. Because even if you had these, if these were different, this would be the approach that you would need to use. So let's go ahead and FOIL. 3 times 2 is 6. 3 times 3x is 9x. Negative 6 times 2 is negative 12x, right? And then negative 6x times 3x is going to be negative 18x squared, correct? Okay. So working this out, combining like terms, all that kind of stuff, I'm going to get 6 minus 3x minus 18x squared, and I get a 2 plus 3x over here, right? Let's remove the 2 from both sides, so subtract there. I'll remove the 3x from both sides, subtract there. So it gives me 0 on the left-hand side. 6 minus 2 is 4. Negative 3 minus negative 3, or sorry, negative 3 minus, I'm wording that wrong, negative 3 plus a negative 3, essentially, or negative 3 minus 3x is going to be negative 6x. Okay? And then negative 18x squared. Is that okay? All right, so we don't like to write it that way. We like it to be in descending order, so we do this. Negative 18x squared minus 6x plus 4. You guys remember doing that in algebra? Okay, just keep position. I'm going to move that thing, so I got to move the sign as well. I kept that one kind of in the middle, right? And then that one needs to move to the end. Over here is the constant, so I take the sign that is in front of it. It's an understood positive, so that's plus 4. So that's how we generate this. Now with this one, there's some issues here that we could address. We don't need to address them now, but maybe you could view this, say everything is divisible by 2, right? Okay, and that might make things a little bit easier, but if you neglect that, maybe we do this problem without taking a 2 out of everything. Taking a 2 out just makes the numbers a little bit easier to deal with. But this approach, we cannot, because this is not a 1, and we don't really have a way of making it a 1 right now. We can't use the technique that says multiply to get 4 and add up to give me negative 6. Okay? But what we can do is look for 2 numbers that multiply together to give me negative 72. So what we're looking for is we're going to take, this is called the A times C method. That's A, and that's C. You multiply them together. So negative 18 times 4 gives you what? Negative 72. Okay? Now I'm looking for 2 numbers that multiply together to give me negative 72. They add to give me negative 6. I'll just help you out. They're negative 12 and positive 6. Okay? You guys remember kind of doing this last year maybe? Some of us?
Yeah.
So these 2 numbers then are going to be how we rewrite our equation. I'm going to leave the negative 18x squared alone, and we'll leave the plus 4 alone. Now this number right here, this negative 6x, gets rewritten as a sum of those 2 things. So negative 12x plus 6x. Would you agree that those red terms are still going to combine to give me negative 6x?
Yes.
Okay. Now the reason we do that is because we're going to group those 2 things right there. And then we're going to group those 2 things. And we're going to look for a GCF, greatest common factor, that exists inside these 2. All right, so what number will divide 18 and 12?
2.
2 will, but there's another one.
4. No.
Not 4. 2 and 3 divide, right? So total of 6.
Yeah.
So let's take out a 6, and it might even be beneficial to take out a negative 6.
Yeah.
Okay? Will x divide both those?
Yeah.
Is x in both those? Yeah. So what I'm trying to do is factor out a GCF. And factoring out a GCF is essentially just taking each term that is in there and dividing it by that GCF. Okay, so what's negative 18 divided by negative 6? 3. What's going to happen with the x squared and the x? Remember, x squared actually means this, right? X times x.
So doesn't it just leave an X?
It just leaves an x, okay? And to know if I did that right, we just factored. So the invert, and factoring is a fancy word for division, okay? So if I want to undo division, what operation do you use to undo division? Multiplication. If I multiply these two things back together, do I get this negative 18x squared?
Yeah.
Yeah, okay? Now I want to take this number here and divide it by that negative 6x. So negative 12x divided by negative 6x, what's going to happen? What do you get?
Negative, no, positive 2X.
Positive 2. What happened to your x's?
Oh, they cancel out.
They should have canceled. Okay? So I get that. Does that make sense to everybody? If I multiply that negative 6x through, if I distribute that through, you get back to negative 18x squared minus 12x. Now I want to do the same thing for 6x plus 4. What number will divide 6x plus 4? 2, right? Okay, 2 is in both those. So let's take a 2 out. And I take a 2 out of here. What do you get? Divide 2 out of 6x, you get 3x. Take a 2 out of 4. Divide 2 out of 4. What do you get? 2. All right. Now, we know that we've done this right when that thing and that thing are the same. You remember seeing that last year?
Yeah.
If those are the same, they become a factor. And what else is a factor?
The negative 6X and the plus 2.
Okay.
Okay.
So the terms that are the same, the expressions that are the same, become one factor, and then the remaining stuff out front becomes the other one, right? How can I know if I've done this right? Could I FOIL this? And if I FOIL that, combine like terms, you will get back up to this phrase right here. That one you started with. Does that make sense? Okay, they're just alternative versions of one another. But why do we like this version better? Because what am I doing between those two quantities? What's the operation? Multiplication. And if you got two things being multiplied together, you get 0. One of them is 0, or both of them is 0. So I get x is equal to negative 2/3 there when I solve for x, right? And here I get x to be, subtract 2 from both sides, so I get, negative 2 over negative 6 eventually, which that gives me 1/3, right? Okay. So I have these two answers, negative 2/3 and what did I say, 1/3?
Yeah.
Okay. Now, you got to be cautious because we may end up with some values here that don't maybe work. Let's plug 1/3 in. Okay, what's 3? Can I clean this up over here? Can I erase this?
Yeah, yeah.
All right, so I'm just going to plug my answers in. So I get 3 minus 6 times 1/3 over 2 plus 3 times 1/3. Does that equal 1 over 2 plus 3 times 1/3? Well, let's think about this. What's 6 times 1/3? 2. So I get 3 minus 2 up top. What's 3 times 1/3?
1.
1. So I get 2 plus 3 on the bottom. Or sorry, 2 plus 1 on the bottom, right?
Yeah.
So 3 on the bottom. Over here, I'm going to get 1, and this becomes 3 on the bottom, right? Are these two things equal? Is 3 minus 2 the same thing as 1?
Yeah.
Yeah. Okay. So that tells me that 1/3 is an answer. Is it doable? Okay. Let's try to evaluate the exact same thing, but now let's use negative 2/3. So put negative 2/3 in here. Put negative 2/3 in there. Put negative 2/3 in there. Up top, okay, what's 2/3 of 6? 4, okay. So I get 3. Now these are a negative and a negative, so they're multiplied together, so that's a positive, right? So it's 3 plus 4. Everybody okay with that? On the bottom, I get 2 plus, now what's 3 times negative 2/3? 3 plus negative, or 3 times negative 2/3?
Two.
2, but it's going to be a positive times a negative, so it's,
Negative.
yeah, it's 2 plus negative 2. What's the issue right there?
You can't have zero on the denominator.
I cannot have 0 on the denominator because it's an undefined value, right? So even though the algebra told me that this is an answer, when we double check it, because we have to do that when we get multiple answers, that's an extraneous solution. All right? It's an answer that does not work. Even though the algebra procedure we went through generates it, it does not satisfy the original proportion. Does that make sense?
Yes.
Okay. I think what's nice is there's a lot of work there, right?
Yeah.
Okay. If you are intelligent about your algebra, like Chuck was, Chuck said, well, my numerators are the same, right? So what did you say about your numerators? Yeah, 3 minus 6x equals 1, and you can solve that equation and get your 1/3 so much faster, right? Okay. That's the great thing about understanding math and how all the ins and outs of it work and being able to analyze a question before you start working. It might kind of delineate down to the best approach to save time. Could I use the quadratic formula there? Instead of the factor by grouping process. This is what I was hoping most people would do, is once they got to, I removed it, I deleted it. Let me go back to this here. If I'm looking at what I've circled here, I was hoping most people would use the opposite of b, plus or minus b squared minus 4ac all over 2a. Does that make sense?
Yeah.
Because that's going to be quicker than that procedure of a times c method. All the factoring that we do in this class, guys, is old information. It was a prerequisite for this course. Okay. Hopefully, if you know you struggle with this, you're using the resources I provide you to go home, do some extra problems, get your issues cleaned up, so that we don't, have to revisit Algebra 1 stuff in the next 3, 4, 5, 6 weeks. Okay? Because this stuff's going to be kind of a constant feature for the rest of the course. The